Assalamu alaikum. I am here Adil Iftikhar with the fourth lecture of DSP. In this lecture we will cover what is DFT and its examples. Now let's start. First of all, one thing to be remembered is that the maximum frequency in digital domain is pi and minimum is 0. Consider this circle. We use this circle to have values of DFT on sub-regular intervals, which are pi, 2 pi, 3 pi by 2 and 0. Now here are some formulas written which shows that these formulas are in analog and these are in discrete, and we have this formula for DFT. Now consider an example. The values are given in time domain and we will use DFT to move towards the frequency domain. Now we have opened this formula. First of all, we have get the value of x of 0, then x of 1, then x of 2 and then x of 3. So these values were in time domain, and by applying DFT we have got some values in the frequency domain. Now then we have to find what is the maximum frequency. Maximum frequency shows that the highest frequency in the time domain. Now let us find the maximum frequency. Here n is equal to 4. 1, 2, 3, 4. 4 values given, so n is equal to 4, and formula is maximum frequency is equal to n over 2. N is equal to 4 over 2, so maximum frequency is equal to 2. And what is the value of 2 here? Is 2. Here we got minus 4, so the maximum frequency is minus 4. So the maximum frequency of this time domain and frequency domain is minus 4. Now here I have done some changes with the given signal. In the first one we have nullified the base signals, and in other we have nullified the extreme signals. Now let's come towards the inverse of DFT. We have formula for inverse of DFT. Why we use inverse of DFT? To move from frequency domain to back towards the time domain. Now we will use these values to get back to the time domain. We have opened these values by using the inverse of DFT, and when you getting these values: minus 1 over 2, 3 by 2, minus 6 by 4 and 1 by 2. Here are some mistakes done by me, and sorry for that, but we have simply got these values: minus 1 by 2, 3 by 2, minus 6 by 4 and 1 by 2. Now here are some diagrams we have drawn here. These are the diagrams of the first signal, and this is the diagram of the second signal. You can show simply the difference between of these two graphs. In the first diagram, it's have high fluctuating values, and it is have high frequency. Whereas in the second graph, it has low frequency and low fluctuating. What does mean fluctuating? Fluctuating mean the rate of change of frequency. If it is changing at a fast pace, we can say that it's a high fluctuating frequency graph. Whereas if it is not changing at a high rate, it is known as low fluctuating graph. So these were the two main differences between these two graphs. If we want to update another one, we can say that this signal shape is like a sinusoidal, whereas the shape of this signal is kind of a semicircle. So these were the differences between these two signals. Now come towards another example. Yes, this is the next example with n is equal to 1, 2, 3, 4, 5, 6, 7, 8. With n is equal to 8, we have used the DFT where we move from time domain to frequency domain. We have all the values get here: 0, 1, 2, 3 up to 7. Now if we want to calculate the maximum frequency, how can we calculate? We have a formula: maximum frequency is equal to n by 2. Here n is 1, 2, 3, 4, 5, 6, 7, 8. Now n is equal to 8, and we'll get a 4 value. Now what is value? Over here on 4 we have 8. So 8 is the maximum frequency of the signal given here in time domain. Now, to get the maximum frequency, we will cut off the first of two frequencies because there is no use of these frequencies. Simply, from the end, we'll cut off these values to get the maximum frequency. Now, if we draw the maximum frequency, we have so we get this signal by applying all the values. So this was the lecture. Thank you for watching.